The Arduino Uno is a small computer board. It is designed to make electronics projects simple for everyone. Think of it as a brain for your inventions. You can connect lights, motors, and sensors to it. Then, you can write simple instructions to tell these parts what to do. This makes the Arduino Uno a wonderful tool for beginners. You do not need a lot of experience to start creating. It is a very popular choice for students, artists, hobbyists, and inventors. The name Uno means one in Italian. This name marks the first official version of the Arduino software. It has become the starting point for countless creative projects around the world. Many people choose the Arduino Uno because it is so easy to use. The hardware is straightforward. The programming language is based on C++, but it is much simpler to learn. A huge community of users exists online. This community shares code, project ideas, and solutions to problems. If you ever get stuck, help is easy to find. This supportive environment makes learning much less intimidating. You can find thousands of tutorials and guides. They walk you through everything from blinking an LED to building a complex robot. This accessibility is the core reason for its massive success. The Arduino Uno is also an open-source platform. This means all the design files for the board are available for free. Anyone can look at them, modify them, and even build their own version of the board. The software used to program the Arduino is also open source and free to download. This philosophy encourages collaboration and innovation. It has led to a vast ecosystem of compatible boards, shields, and accessories. Shields are extra boards that plug right on top of the Uno. They add new capabilities like Wi-Fi, motor control, or GPS without messy wiring. Getting started is not expensive. The Arduino Uno board itself is very affordable. Most of the basic components you will need, like wires, resistors, and LEDs, also cost very little. This low cost of entry removes a major barrier for people who are just curious about electronics. You can buy a starter kit that includes an Arduino Uno and a wide variety of parts. These kits often come with a guidebook full of simple projects to build. This allows you to learn by doing, which is honestly the best way to master any new skill. The Arduino Uno truly opens the door to the exciting world of electronics for everyone. The Arduino Uno is built around a specific microcontroller chip. This chip is the Atmega 328P. It acts as the board's brain. The microcontroller runs at a clock speed of 16 MHz. This means it can perform 16 million operations per second. This speed is more than enough for most beginner and intermediate projects. The board has a built-in USB interface. This allows you to connect it directly to your computer. The USB connection is used for two main things. First, it provides power to the board. Second, it lets you upload your programs, which are called sketches, from your computer to the board. The board features a specific number of input and output pins. These are the connection points for your electronic components. The Arduino Uno has 14 digital pins. These pins can be either on or off, like a light switch. They can be configured as either inputs or outputs. 6 of these 14 digital pins have a special ability. They can produce a simulated analog signal using a technique called pulse width modulation, or PWM. The board also has 6 dedicated analog input pins. These pins can read a range of voltage levels. This is useful for reading data from sensors that provide a variable signal, not just on or off. Memory is another important feature of the Arduino Uno. The board has 3 different types of memory. It has 32 kilobytes of flash memory. This is where your program or sketch is stored permanently. The flash memory keeps your code safe even when the power is turned off. The board also has 2 kilobytes of SRAM, which stands for Static Random Access Memory. This is where your program creates and uses variables while it is running. SRAM is temporary memory. Its contents are lost when the power is disconnected. Finally, there is 1 kilobyte of EEPROM. This is a special type of memory that can store small amounts of data permanently, similar to a small hard drive. The physical size and operating voltage are also key characteristics. The Arduino Uno board is quite small, measuring about 68.6 mm by 53.4 mm. This compact size makes it easy to fit into many different types of projects. The board operates at a voltage of 5 volts. This is a standard and safe voltage for hobby electronics. The pins also operate at 5 volts. This is important to know when you connect other devices and sensors. You must make sure they are compatible with this voltage level. Using components that require a different voltage might damage them or the Arduino board itself. Let's look at the layout of the Arduino Uno board. The most important component is the large black chip in the middle. This is the Atmega 328P microcontroller. It is the brain that runs your code and controls everything. Think of it as the central processing unit or CPU of your small computer. All the other parts on the board are there to support this chip. They help it receive power, communicate with your computer, and connect to other electronic parts. The microcontroller is often seated in a socket. This means you can carefully remove it and replace it if it ever gets damaged, which is honestly a very useful feature. Near one edge of the board you will find the USB port. This is a standard Type B USB connector similar to one you might find on a printer. This port is your main link to your computer. You will use a USB cable to connect the Arduino to your PC or Mac. This connection provides power to the board and allows the Arduino IDE software on your computer to send your compiled code, your sketch, directly to the microcontroller's memory. This makes programming the board incredibly simple and convenient. Next to the USB port, there is often a small silver cylinder. This is the 16 MHz crystal oscillator, which acts like a clock, setting the speed for the microcontroller. Right next to the USB port is the power jack. This is a barrel-style power connector. It provides an alternative way to power your Arduino. You can plug in a wall adapter or a battery pack here. This is useful when your project needs to run without being connected to a computer. The board has a built-in voltage regulator. This component takes a higher input voltage from the power jack, typically between 7 and 12 volts, and safely converts it down to the 5 volts that the board needs to operate. This protects the delicate microcontroller from being damaged by too much voltage. You will also see rows of black plastic strips with holes in them along the edges of the board. These are the female pin headers. These headers are where you will plug in wires to connect your sensors, LEDs, motors, and other components. Each hole is connected to a specific pin on the microcontroller. The headers are clearly labeled to tell you what each pin does. You will also find a small button on the board, usually near the USB port. This is the reset button. Pressing this button will stop your program and restart it from the beginning, just like restarting your computer. The pins on the Arduino Uno are your gateway to building circuits. Let's start with the digital pins. These are found in a long row and are labeled from 0 to 13. A digital pin can be in one of two states, high or low. A high state means the pin is outputting 5 volts. A low state means it is outputting 0 volts. You can use these pins to turn things on and off like an LED. You can also set them as inputs to read a digital signal from a switch or a button. For example, you can check if a button is pressed, which would be high, or not pressed, which would be low. Some of the digital pins have a special symbol next to their number, a tilde. These are the PWM pins. They are pins 3, 5, 6, 9, 10, and 11. PWM stands for pulse width modulation. This is a clever technique that lets the digital pin create a signal that acts like an analog one. It works by switching the pin between high and low very quickly. By changing how long the pin stays high compared to how long it stays low, you can vary the average voltage. This is very useful for tasks like controlling the brightness of an LED or changing the speed of a DC motor. On the opposite side of the board you will find a smaller group of pins labeled a 0 to a 5. These are the analog input pins. Unlike digital pins that only see high or low, these pins can read a continuous range of voltages. They can detect voltage levels anywhere between 0 volts and 5 volts. The board has a 10-bit analog to digital converter. This means it can translate the incoming voltage into a number between 0 and 1023. This capability is essential for working with many types of sensors. For instance, a temperature sensor or a light sensor will output a variable voltage that you can read with these analog pins. Finally, there are the power pins. These are not for data, but for supplying electricity to your circuits. You will find several of these pins grouped together. The pin labeled 5V provides a regulated 5-volt supply directly from the board. The pin labeled 3.3V provides a 3.3-volt supply. Several pins are labeled GND, which stands for ground. Ground is the common reference point for all voltages in your circuit. You must always connect the ground of your external components back to one of the Arduino's GND pins to complete the circuit. There is also a VIN pin, which can be used to power the board directly with an unregulated voltage source. So, let's talk about how your Arduino Uno actually communicates with other devices. You know, it often needs to talk to your computer, to other Arduinos, or even to some pretty complex sensors and modules. And well, it does this using several standard methods or protocols. The most common one is serial communication, which is also called UART. This is the protocol that goes over the USB cable when your Arduino talks to your computer. The digital pins 0, labeled RX for receive, and 1, labeled TX for transmit, are dedicated hardware serial pins. Whenever you upload a sketch or use the serial monitor in the Arduino IDE, those pins are active. It's usually best to avoid using pins 0 and 1 for other things if you're relying on serial communication. Another really important communication protocol is I2C, which stands for Inter-Integrated Circuit. This one's super useful because it lets you connect a bunch of devices to your Arduino using just 2 wires. One wire is for the data line called SDA, and the other is for the clock line called SCL. On the Arduino Uno, the SDA pin is a 4 and the SCL pin is a 5. A lot of modern sensors like accelerometers, gyroscopes, or OLED screens use I2C. Each device on the I2C bus has its own unique address. Your Arduino acts as the master and sends commands to the specific address of the slave device it wants to talk to. This setup really helps keep the wiring neat, especially for bigger projects. Now, the third major protocol is SPI, or Serial Peripheral Interface. SPI is generally faster than I2C and is often used with devices that need to transfer a lot of data quickly, like SD card modules or certain types of display screens. SPI does use more wires than I2C, usually 4 MISO, which stands for Master In, Slave Out, MOSI, which is Master Out, Slave In, SCK, or Serial Clock, and SS, which is Slave Select. On the Arduino Uno, MOSI is pin 11, MISO is pin 12, and SCK is pin 13. Pin 10 is traditionally used as the SS pin, but honestly, you can use any digital pin for that. The SS pin is what selects which specific device your master Arduino wants to communicate with. Once you understand these protocols, you can really open up a whole world of possibilities. I mean, sure, you can control simple LEDs and buttons with the basic digital and analog pins, but these communication methods let you work with way more advanced components. The Arduino language even comes with built-in libraries that make using these protocols a breeze. For example, the UART library takes care of all the tricky parts of I2C communication for you, and in the same way, the SPI-H library makes SPI communication super straightforward. All you really need to know is which pins to connect your device to, and then just a few simple commands will get you sending and receiving data with all kinds of powerful electronic modules. There are several ways to provide power to your Arduino Uno board. The easiest method, especially when you are programming, is to use the USB cable. When you connect the Arduino to your computer, the USB port provides a steady 5 volts of power. This is enough to run the board and many small components like LEDs and simple sensors. This is the perfect option when you are developing your code and testing your circuits at your desk. It is simple, convenient, and you do not need any extra power supplies. However, your project will always need to be tethered to your computer. For a standalone project that needs to be portable or placed far from a computer, you will need an external power source. The most common way to do this is through the barrel power jack. You can plug in a wall wart AC to DC adapter similar to one you might use for a router. The Arduino's onboard voltage regulator can handle an input voltage between 7 and 12 volts. A 9-volt adapter is a very common and safe choice. The regulator will take this higher voltage and convert it down to the stable 5 volts the microcontroller needs. You can also use a 9-volt battery clip attached to a barrel plug to make your project truly portable. A third option is to supply power directly through the board's power pins. The VIN pin is a direct input to the voltage regulator, just like the barrel jack. You can connect an external power source like a battery pack with 7 to 12 volts directly to the VIN and GND pins. This is useful if you are building your project into a custom enclosure and cannot use the bulky barrel jack. Be very careful to connect the positive wire to VIN and the negative wire to GND. Reversing the polarity can permanently damage your board. This method is for more advanced users who are comfortable with their wiring. It is also possible to bypass the voltage regulator and power the board directly with a regulated 5-volt source. You can do this by connecting your 5-volt supply to the 5V pin and the ground to the GND pin. This method should only be used if you are absolutely sure your power source is clean and stable at exactly 5 volts. Any voltage higher than 5.5 volts on this pin can destroy the Atmega 328P chip. This method is typically used in advanced projects where the Arduino is being integrated into a larger circuit that already has its own regulated 5-volt power supply. For beginners, it is safest to stick with USB power or a 7 to 12 volt supply through the barrel jack or VIN pin. Programming your Arduino Uno is done using the Arduino Integrated Development Environment, or Arduino IDE. This is a free software program that you can download from the official Arduino website, arduino.cc. The IDE is a simple text editor where you write your code. Once you have written your instructions, the IDE compiles the code. Compiling means translating your human-readable code into the machine language that the microcontroller can understand. The IDE runs on Windows, Mac, and Linux, so you can use it on almost any computer. It provides a single, unified environment for writing, checking, and uploading your code. The programs you write for Arduino are called sketches. Every Arduino sketch has two main parts, setup and loop. The setup function runs only once right after the Arduino is powered on or reset. You use this section to do initial setup tasks. For example, you would use setup to tell the Arduino which pins you are using as outputs and which you are using as inputs. The loop function is the heart of your program. After setup is finished, the code inside loop runs over and over again continuously, as long as the board has power. This is where you put the main logic of your project, like reading a sensor and turning on a light. Once your sketch is written, you need to upload it to the Arduino board. First, connect your Arduino Uno to your computer with a USB cable. In the Arduino IDE, go to the Tools menu. You need to select the correct board, which is Arduino Uno. You also need to select the correct serial port. This is the communication channel your computer uses to talk to the Arduino. It will usually be labeled with Arduino Uno next to it. After that, you just click the Upload button, which is an arrow icon at the top of the IDE. The IDE will compile your sketch and send it to the board. You will see some lights on the board flicker, and then your new program will start running. This easy upload process is made possible by a special piece of software called the bootloader. The bootloader is a small program that comes pre-installed on the ATmega 328P chip on every new Arduino Uno. When you power up or reset the board, the bootloader runs for a few seconds. It checks to see if the computer is trying to send a new sketch. If it detects an incoming program, it receives the code and writes it to the flash memory. If no new sketch is being uploaded, the bootloader simply starts running the sketch that is already stored in memory. The bootloader is what allows you to program the Arduino with just a simple USB cable, without needing any expensive, specialized programming hardware. The Arduino Uno's microcontroller, the ATmega 328P, has three distinct types of memory, each serving a different purpose. The first and largest is the flash memory. The Uno has 32 kilobytes of flash. This is non-volatile memory, which means it holds its contents even when the power is turned off. This is where your sketch is stored. When you click the Upload button in the Arduino IDE, your compiled program is sent to the board and written into this flash memory. The bootloader program also takes up a small amount of this space, usually about half a kilobyte, leaving you with around 31.5 kilobytes for your code. For most projects, this is plenty of space. The second type of memory is SRAM, which stands for Static Random Access Memory. The Arduino Uno has 2 kilobytes of SRAM. This is volatile memory, meaning its contents are erased as soon as the board loses power. SRAM is used by your sketch while it is running. It is where your program stores variables, manages function calls, and performs calculations. Think of it as the microcontroller's short-term working memory. It is much faster to read and write than flash memory. If your program uses too many variables or has very complex data structures, you might run out of SRAM, which can cause your program to behave strangely or crash without warning. The third type of memory is EEPROM, which stands for Electrically Erasable Programmable Read-Only Memory. The Uno has 1 kilobyte of EEPROM. Like flash memory, EEPROM is non-volatile, so it retains data without power. However, unlike flash memory where the whole sketch is stored, you can read and write to individual bytes of EEPROM from within your running sketch. This makes it perfect for storing small amounts of data that need to be remembered between power cycles. For example, you could use EEPROM to save user settings, a high score for a game, or calibration data for a sensor. Understanding the differences between these memory types is crucial for writing efficient and reliable code. You store your program's instructions in flash. You use SRAM for temporary variables that change often while the program runs. You use EEPROM for long-term storage of small amounts of important data that need to survive a power outage. The Arduino language provides specific commands to work with EEPROM. Using the EEPROM.h library, you can easily write a value to a specific EEPROM address or read a value back. Be aware that EEPROM has a limited number of write cycles, so you should only write to it when necessary. The true fun of Arduino begins when you start building things. The possibilities are nearly endless, even with a simple board like the Uno. A classic first project is the blink sketch, which simply blinks an LED on and off. This teaches you the basic structure of a program and how to control a digital output. From there you could build a traffic light system with red, yellow, and green LEDs. You could also create an interactive game by adding buttons as inputs. Another great beginner project is to use a photoresistor, a light sensor, to automatically turn on an LED when the room gets dark. As you get more comfortable, you can tackle more complex projects. You can control the position of a servo motor to build a small robotic arm or an automatic cat feeder. By connecting a temperature sensor like the TMP36, you can build a digital thermometer that shows the temperature on an LCD screen. You can even make musical projects by connecting a small speaker or piezo buzzer and programming it to play simple tunes. The Arduino Uno can also be the brain of a small mobile robot, using distance sensors to avoid obstacles and motors to drive the wheels. These projects teach you about sensors, motors, and displays. Sometimes your projects will not work on the first try. This is a normal part of learning. If you get an error when uploading your sketch, first check your connections. Is the USB cable plugged in securely? In the Arduino IDE, double-check that you have selected Arduino Uno under Tools Board and the correct COM port under Tools port. If the code runs but does not do what you expect, use the serial monitor. You can add serial.println commands in your code to print the values of variables. This helps you see what the Arduino is thinking and can help you find logical errors in your code. For further learning, the internet is your best friend. The official Arduino website, arduino.cc, has excellent tutorials and a detailed language reference. Websites like Adafruit, SparkFun, and Instructables have thousands of project guides with step-by-step instructions and code examples. YouTube is also a fantastic resource, with countless channels dedicated to Arduino tutorials for all skill levels. Books are also a great way to learn. My own book, Programming Arduino Getting Started with Sketches, is designed to take you from a complete beginner to a confident creator. Do not be afraid to experiment, make mistakes, and ask for help from the large and friendly online community. The most important step is to start.